Hello dear students, today I am going to discuss the last part of this chapter, understanding elementary shapes. In this video I am going to discuss many topics so that the length of video will be little more compared to the other videos. So keep patience and watch the full video till the end. The main topics I am going to discuss in this video are classification of quadrilaterals, then polygons, three-dimensional shapes. So first let's start with the classification of quadrilaterals. Based on the properties of quadrilaterals, they are classified into 5 categories. One is parallelogram, rhombus, rectangle, square and trapezium. So first let's start with parallelogram. What is a parallelogram? A quadrilateral with each pair of opposite sides are parallel. That means AB parallel to DC. AB parallel to DC and AD parallel to BC. AD parallel to BC. That means opposite sides are parallel. Then we can call that quadrilateral is a parallelogram. So the first property of parallelogram is opposite sides are parallel. Then what is the second property? Opposite sides are equal. If opposite sides are parallel, then obviously the length of the side also will be equal. That means AB is equal to DC. AB equal to DC and AD equal to BC. These two sides are equal. Then the third property is that opposite angles are equal. Not only opposite sides are equal, also opposite angles equal. That means angle A equal to angle C and angle B equal to angle D. These two are the opposite angles. Clear? The next, the diagonals of parallelogram are not necessary to be equal. Okay, so that is not the property of parallelogram. Second type of quadrilateral is rhombus. A parallelogram with sides of equal length. That means what are the properties applicable to parallelogram? All those properties also applicable to rhombus. In addition to that, all sides are equal. So what is the first property we have learned? That is all opposite sides are parallel. That means AB parallel to DC and AD parallel to BC. That is a property of parallelogram. Then what is the second property? That is a special condition for a rhombus. That is all sides are equal. AB is equal to BC equal to CD equal to DA. All sides are equal. Then opposite angles are equal. Same as we discussed in the case of parallelogram. Opposite angles are equal. Angle A is equal to angle C and angle B equal to angle D. One more condition is that diagonals are perpendicular. That means the diagonal AC and BD are perpendicular to each other. AC perpendicular to BD. That is the one more condition for a quadrilateral to be a rhombus. Okay. Then third one, rectangle. A parallelogram with a right angle. Clear. All the properties of parallelogram. In addition to that, all the interior angles should be right angle. Properties are opposite sides are parallel, opposite sides are equal, and each of the angle is a right angle. That is a special case. Each of the angle is a right angle. All angles are equal and all angles are equal. Measure of all angles are equal to 90 degree. Angle A equal to angle B equal to angle C equal to angle D equal to 90 degree. One more condition is that diagonals are equal. That is AC equal to BD. Diagonals also equal. Clear? Then the fourth type of quadrilateral is the square. That means all the properties of rectangle, rhombus and parallelogram will be applicable to square. First property is that opposite sides are parallel. Okay, and all sides are equal. Okay, each of the angle is a right angle. Clear? And so opposite sides are parallel. That is a property of parallelogram. All sides are equal. That is a property of rhombus. and each of angle is a right angle, that is a property of rectangle. That means the property of parallelogram, rhombus, and the rectangle. And the addition to that we can say diagonals are equal. AC equal to BD. Clear? AC equal to BD and the diagonals are perpendicular. AC perpendicular to BD. Clear? So a square has all the properties of parallelogram, rhombus and rectangle. And the fifth one is the trapezium. A trapezium is a quadrilateral with a pair of parallel sides. In a quadrilateral, if any two sides are parallel, then we can call that is a trapezium. Here AB parallel to DC. So this is the main property of trapezium. Clear? In addition to the properties we discussed in this video, there are some more properties are there which you will learn in higher classes. Okay. So this is very important classification of quadrilaterals. Next, we can just sum up the properties what we have discussed now here. Okay, this table will help you to get a quick idea about all types of quadrilateral. Here opposite sides, whether it is parallel or equal, and all sides are equal or not, like that it is. Okay, so this table is very important. You can copy to your notebook so that it will be helpful to understand the differences between the each type of quadrilaterals at a glance. Next topic is that polygon. Polygon, we have discussed what is a polygon and the diagonals of polygon, elements of polygon, everything we have discussed already in the previous chapter. Here just we are going to classify the polygons based on the number of sides present in the polygon. Here, if the number of sides are 3, then we will call that is a triangle. You can see here the picture of triangle. And if the number of sides is 4, then obviously we will call that is a quadrilateral. These two type of polygons we already discussed in detail. And if the number of sides is 5, then we will call that is a pentagon. Here you can see this polygon has 5 sides. And if the number of sides is 6, then obviously we will call that is a hexagon. Here you can see a hexagon. And if the number of sides is 8, then we will call that is an octagon. In addition to the polygons we have discussed here, there are some more polygons are there which you will learn in higher classes. Like if the number of sides are 7, then we will call that is a septagon. Okay, so that you will learn in later classes. So the last topic of the chapter, that is three-dimensional shape. Till now we discussed about two-dimensional shape. Okay, that means plane figure. Now we are going to discuss solid figure. In geometry, a three-dimensional shape can be defined as a solid figure or an object or a shape that has 3 dimensions. For example, in case of rectangle, we have 2 dimensions, length and breadth. So that's why it is called a two-dimensional figure, and it is a plane figure. While in case of three-dimensional figure or three-dimensional shapes, it has 3 dimensions. For example, we can take a cube is an example of three-dimensional shape. This is a cube. Okay, it is a box shape of a square. It has 3 dimensions: length, breadth and height. Length, breadth and height. These are the 3 dimensions of a cube. This is a length and this is a breadth and this is a height. How to draw a cube? You might be already know, but still I will discuss. First draw a square. Okay. Then draw again one more square like this. Okay. Keep some distance from the first square. Then join these 2 vertices of square. Okay. Then join these 2 vertices. Again join these 2 vertices. Then finally we can join these 2 vertices. Now it is a shape of a cube. Elements of three-dimensional shape. What are the elements of three-dimensional shape? First one is face. A flat surface of a 3D shape is called face. If a three-dimensional shape has flat surface, then we will call that as a face. So this is one of the face of a cube. Clear? This is also face, this is also face. So this flat surface is called a face. and two faces meet at a line segment is called an edge. Here you can see that this is one face and this is another face. Clear? And these two faces are joined by this line segment which is called edge. So this is an edge, this is an edge, this is also an edge. Okay. And the three edges meet at a point is called a vertex. Here you can see, here one edge is there, and here another second one, and here upward third one. So these three edges meet at a point. That point is called the vertex of the 3D shape. So what are the three elements? Face, edge, and vertex. Now let's discuss regarding some important three-dimensional shapes. First one, we can start with the cuboid. What is a cuboid? A cuboid looks like a rectangular box. Clear? It is a box type of a rectangle. It has 6 faces, which means it has 3 pairs of equal faces. Here one face is there. Okay. Here also same faces. So 2 faces are there with the same area. And here also one more face. Here also another face. Okay, these two are front and back face. These are side face. And one top face is there. Okay, and one bottom face is there. Clear? So totally it has 6 faces. And each face has 4 edges. For example, if you consider the front face, it has 4 edges. 1, 2, 3 and 4. And each face has 4 vertices. First vertex, second vertex, third vertex, and fourth vertex. So totally a cuboid has 12 edges and 8 vertices. You can count it out. Okay, let's count it. 1, 2, 3, 4. Okay, 5, 6, 7, 8, 9. Okay, 10, 11 and 12. So total a cuboid has 12 edges. And how many vertices are there? 8. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Next is the second type is a cube. A cube is a cuboid whose all edges are of equal length. Here the all edges are not equal. This is the length, this is the breadth, and this is the height. These all edges are not equal length. But here in this case of cube, all edges are equal. That's why this is called a cube. It has all the properties same as in case of cuboid. Only the difference, the only one difference between cuboid and cube is that cube is a cuboid whose all edges are of equal length. The all properties are same. Clear? And the third one is a pyramid. A pyramid is a shape with a single base. The other faces are triangles. There are 2 types of pyramids we are going to discuss here. So first let's discuss the triangular pyramid. Here you can see this is the base surface. The shaded portion is base surface. Okay. And the other, this is the front one, and these 2 are the side faces. The other faces are in the shape of a triangle. Okay. Base can be in any shape, but the other faces should be triangle. It has a triangle as its base. It is also known as tetrahedron. These are the properties of triangular pyramid. And it has 4 faces. One is base and the other 3 are, this is the front one. Okay, this picture will help you to understand how many faces are there. 1, 2, 3. These are the 3 side faces. And one more base face. So total 4 faces are there. How many edges are there? 1, 2, 3, 4, 5 and 6. And how many vertices? 4 vertices. 1, 2, 3 and 4. Next one is square pyramid. Square pyramid is same as the triangular pyramid. Only the difference is that its base is in the shape of a square. A square pyramid has a square as its base. Here the shaded portion is a base and other faces are triangular. It has 5 faces. One is base and there are other 4 faces. 1, 2, 3 and back also one more face is there. It has 8 edges. 4 edges on the base part. Okay, and 5, 6, 7 and 8. And lastly, it has 5 vertices. How many vertices are there? 1, 2, 3, 4 and 5. Now I will show a 3-dimensional simulation of square pyramid so that you will get a clear idea about the shape. Okay, here you can see this is a square pyramid. Okay, this is the base surface and you can see 4 side surfaces which are in triangular shape. Clear? So now let's move to the another 3-dimensional shape, that is triangular prism. We are going to discuss. It is look like a shape of a kaleidoscope which you have already learned in science. What is a kaleidoscope and the purpose of kaleidoscope. So here we are going to discuss only the geometrical part of that shape, triangular prism. A triangular prism is look like this. 2 base surfaces are there. This shaded portion is base surface. That means these 2 bases are in the form of a triangle and other faces are first front face, back face and the bottom face. The other 3 faces are in the shape of a rectangle. Okay, it has 5 faces totally. It has 2 base faces, that is triangles, and other 3 faces are in the shape of a rectangle. That means 3 plus 2 totally 5 faces. It has 9 edges. You can count it. Okay, you can draw a plain triangular prism figure without shading so that you can easily count how many edges are there. And it has 6 vertices. Okay, 1, 2, 3, 4, 5 and 6. Here I will show a 3D simulation of triangular prism. Okay, this is a 3-dimensional structure of the prism. 2 triangles are the first one and second one. These are the 2 base surfaces. And look at the other faces. This is a rectangle and these 2 also rectangle. Okay, that means total 3 rectangular faces and 2 triangular faces. And this triangular faces is known as base. Next we are going to discuss some of the other types of 3-dimensional shape, which is cylinder, cone and sphere. These 3 shapes have a small difference from the other shapes, which means these 3 shapes have curved surfaces in addition to flat surface. So first let's start with the cylinder. This is the shape of a cylinder. Okay, it has no straight edge. That is the first property. All edges are curved. It's in the form of a circular path. It has 2 bases, top and bottom face. Here also one similar face is there. Its base is a circle. Its base surface is a circle. Here I will show the 3-dimensional simulation of cylinder. You can see here. First base, second base, which is in the form of circle. And this is a curved surface. Clear? For example, we can consider a pipe. A piece of pipe is in the shape of a cylinder. Next one is cone. It has no straight edge, same as in the case of a cylinder. And its base is a circle. Unlike a cylinder, it has only one base surface, that is a circle. You can see here, this is a cone. Base surface, circle, and this is a curved surface. It has one flat face is there, that is in the shape of a circle, and one curved face is there. And the last one is sphere. A sphere has no flat surface and no straight edges. Nothing is there. For example, a ball, football or basketball is in the shape of a sphere. Clear? It does not have any flat surface, completely curved. And it does not have any straight edge. Clear? But still, these are three-dimensional because the three dimensions which we have discussed in case of cube and cuboid are length, breadth and height. While in case of sphere, cone and cylinder, the three dimensions you are not studied at all because you studied up to length, breadth and height. So to express the three dimensions of sphere, cone and cylinder, which we will use another type of system which is a part of high level mathematics, so that you will learn in later classes. So with this I have completed the chapter understanding elementary shapes. The topics which I have explained today is very important. So just note the points, important points given in this video, and in the next video I will come with another chapter. Thank you all.